All right, this video is going to go over how we find arc length for polar curves. Again, if you are in my course, I'm going to give you this formula, so you don't need to memorize it. It does come from the parametric equation and how we find arc length using the parametric equation. But let's just go over some examples of how we're going to use this. So let's find the arc length of the cardioid 2 plus 2 cosine theta. And again, to graph this, let's go ahead and say, okay, if we have 0, then 2 plus 2 gives me 4. So 0, 4 is my start. If I go to pi over 4, I get 2 plus root 2. So like 2, 3 and a little bit. Pi over 2 ends up being 2 plus 0. So I end up going in this way. We know that cosine is negative, so 2 all the way up to that 0 term is going to end up giving me this little bubble. And then I'm going to have a symmetric part over here. Now, because of the symmetry of this, I can just use my formula from 0 to pi and then double it, okay? And so I'm going to end up doing r squared plus dr d theta squared. So what's r prime with respect to theta? Negative 2 sine theta. So negative 2 sine theta squared d theta. Let's see what ends up happening inside this square root when I expand. So I'm going to have 2 integral from 0 to pi. Inside this square root, I have 4 plus 8 cosine theta plus 4 cosine squared theta. Over here, I end up getting plus 4 sine squared theta. I factor out a 4, and then sine squared and cosine squared is 1, so I end up getting 8 plus 8 cosine theta inside my square root. I could factor out an 8. I could factor out a 4 if I wanted to. I could do a couple different things here, but one thing I want us to kind of recognize is that cosine squared theta is equal to 1 plus cosine 2 theta over 2. And so if I take this 2 over here and then multiply both sides by 8, so that I would have 8, and so I'd have 16 here, then I can replace 8 plus 8 cosine theta with 16 cosine squared of theta over 2. And that's something I can take the square root of, right? All right, I'm going to rewrite this all up in this space up here. Let me erase that. Okay, so I'm going to double the arc length from 0 to pi of 4 cosine theta over 2 d theta. 2 times 4, that gives me 8. Sine theta over 2. Ooh, but I have a theta over 2, so this actually gives me 16 from 0 to pi. 16 times the sine of pi over 2 minus 0 ends up giving me 16. So this has a length total of 16 units. A little extension question here. How could I figure out when the slope of the tangent line is going to be horizontal? So let's think about that. When is the slope of the tangent line horizontal? Well, that's when the change in y over the change in x is 0, right? Or when my change in y is really 0. Well, what is y? Y is equal to r, and I always have to kind of write this out. This is x, this is y. So sine, r sine theta. So in this case, y would be equal to, what was our r again? R was 2 plus 2 cosine theta times sine theta. And I want to figure out y prime with respect to theta. This ends up giving me 2 sine theta plus 2 sine cosine theta is sine of 2 theta. So that's where a double angle is really nice. So y prime is equal to 2 cosine theta plus 2 cosine 2 theta. And I want to know, when is that equal to 0? I'm going to just use Desmos in order to figure that out. And I'm going to do it like as a y equals x. So y equals 2 cosine of x plus 2 cosine of 2x. And I want to know the zeros. That's going to be at pi over 3 and pi and 5 pi over 3. And then let's go connect it up to the graph. And then again at 2 pi. No, I lied. 7 pi over 3. Okay. So let's go up here and look. Now 7 pi over 3, that's actually bigger, right, than 2 pi. So I'm not going to worry about that. But pi over 3, if you look at pi over 3, I mean, that makes sense, right? Now let's look at pi. What happens here? I end up having a sharp turn, right? So yes, it makes sense that my slopes will end up going to 0 there, but really like r prime is going to be undefined. And then it said 5 pi over 3. Yep, that makes sense as well. So you might need to use some of these formulas from both polar and stuff that you know from Cal 1 in order to figure out like certain attributes on these polar functions.